Hello, this is Dr. Marina Nawal Sabrajmayel from the Lebanese University. In this chapter on PLCs, we are going to talk about the Rockwell automation addressing and instructions. We are going to talk about Rockwell PLCs because the simulator we are going to use is the Logix Pro simulator, and Logix Pro simulator is from Rockwell automation. This is why we are going to look at the functions of Rockwell, but usually they are not very different from one PLC to the other. So in this chapter, we are going to begin with the memory addressing, talk about the program file memory, data file memory. Then we're going to look at the addressing method of each of the data file memory files, like input, output, bit, timer, counter, integer, and floating numbers, as well as strings. So when I talk about the memory address, when I address to program a PLC, everything that the user needs, we are dividing the memory into two main parts, the program memory and the data memory. In the program memory, there is controller information. There is the main ladder program, our program, and the subroutine programs that we could add to the program. In the data memory, we have the inputs, the image of the inputs, and the output image table as well. We also have all the rest of the data files that we are going to discuss. In the program file memory, it is divided into three main files. The first one is system-related information. The second one is reserved for the internal execution, internal functioning of the PLC. And in the third file, we have the main ladder program. And the rest of the files, we have the user created for subroutines. So we have the main and the subroutine programs in files 2 and 3 onwards. But these file addressing, we as programmers, we don't have to know where the program is saved or where the subprograms are saved. This is an internal organization of the PLC. Whereas when I talk about the data memory, we have to know where the data is saved because we are going to address them from within the program. So we have, for example, the outputs are saved in file 0, the inputs in file 1. We have the bits in file 3, timers in file 4, and counters in file 5. These are the main files that we use within our programs. To address them, to address each data kind, we have an identifier for it, and we have a file number. So in this table, we have the list of the identifiers and file numbers that we have in the Rockwell automation PLCs. So we have letter O as an identifier for outputs and the file number 0. For inputs, I have the letter I and file number 1. The status, I have the letter S, and later on we are going to see examples on how to use status bits because some of them are information that is already saved within the PLC that we are going to retrieve and use in our programs, and so on. So bits B, timers T, so counters C, and integers N. If I look at an address like this one, I have a lot of numbers. The first is the identifier and the file number, so it's I1 to identify that it is the input. I have then what we call the slot delimiter. This slot delimiter indicates which module of input I am talking about, because sometimes you can have more than one inputs module, and each one can contain up to 16 inputs. Because each input in the digital corresponds to only one bit in the memory, therefore every word in the file, which is 16 bits, can contain information for up to 16 different inputs. So if I have more than 16 inputs, I have to take another input module. Therefore, I have to take another slot number. So I have a slot delimiter and a slot number. This is where I want to plug in the input module. Then I have the slash, and slash is always representing the bit delimiter. So after the slash is the bit number. If I have a whole module of 16 bits and I want to know which input I am addressing, I have to, within the module, check the address, check the number of the input. So if I take an example here, I have a PLC where on the first rack, a slot of the rack, I have the CPU, Then I have 3 input modules and 3 output modules. So I have their addresses in here, their slot numbers below. Inputs are on slots 1, 2, 3, outputs on slots 4, 5, 6. So if I want to go back to this and address the first input on the first input module. So this is going to be I1, because this is the identifier of the input, then the slot delimiter, then because the first input module happens to be on slot number 1, I'm going to put 1, then slash, the first input has an address 0, so it's going to be /0. The second input on the third input module is this one, so it's on slot number 3, so it's going to be I1 colon 3 slash, it is the second input, therefore it is the number 1. And so on. The fifth input on the second input module is going to be I1 colon 2 slash 4. Addressing outputs. If I want to address an output, it's exactly the same way. In here we have added an additional information that is rarely used, which is the word. I have the output, the file number, then the slot delimiter, the slot number. In case a slot has more than 16, so the module has more than 16 outputs, I can divide this address into 2 different words. So it could be 5.0 and 5.1. But as I said before, this is rarely used. Slash number of the output. Again, in here, just we'll take one of the examples. First output on the first output module, because the first output module is on slot number 5, so this is going to be O0 colon 4 slash 0, because the first address is on the address 0. The bits are addressed in the same way like inputs and outputs. The only difference is that they don't have external access, so I do not have a slot number. Instead, I call it an element delimiter and element number because it is just an address in the memory. So bit and file number 3, the colon is the element delimiter. This is number 64 in the memory addresses. Slash 12, we can go up to 15 because we have 16 different bits. The timers, on the other hand, instead of taking only one word in the memory, they take 3 words. One is for the preset value. This is the value we want to ask the timer to count to. The accumulated value is the actual value in the memory where the timer is counting. And we have a set of bits. We need from these 3 special bits that are the enable. This is the input to the timer. The timer timing is on when the timer is timing, and the done, this is when the timer finishes timing, or it is practically the output of the timer. So all of these are addressed by T4. In here we have chosen the 8th timer, so T4 7. The bits are like before addressed with a slash. We call them with their names, not their numbers. So EN for enable, TT for timer timing, and DN for done. Whereas when I want to address words inside the timer, I put a dot instead of putting a slash. So every time I want to address words, I put a dot. And every time I want to address an element or a bit, I put a slash. So here are some examples. Timer 7 enable bit, preset value, accumulated value, and the answers are every time I have a bit I have to put a slash. Enable, for example, dot preset, this is timer number 1. If I had said the first timer, it would be timer number 0, and so on. Counter addressing are very similar to timer addressing because they also need 3 different words. They have a preset value and accumulated value. Of course, counters work in a different way with respect to timers. We have a special chapter for timers and counters. We have also elements. We have bits. We need from them the enable bit and the done bit of the counters. We also address them in a very similar way. We have counter 7 enable bit, so this is file number 5 for counters. Number 7, this is the 8th counter, counter number 7 slash enable, and the dot for every time I have a word. Integers are saved on a 16-bit on a whole word, and I need to address the whole word to get the value because they are not digital anymore, they are real values. Therefore, I have the address which is smaller because I have to address the integer file, then I have to address the whole address word of the integer. So I don't have neither a dot nor a slash after that because it addresses exactly one word in the memory. The floating point addresses two word memory, and I have the address of a floating point which reserves directly two addresses, and the second element of a floating number is going to start two addresses after that. A string is the largest file and it contains up to 32. I have up to 42 word elements. And the first one is going to contain the actual length of the string so that it doesn't end with zeros or just anything. And the string reads every 15-bit or every word address in the memory corresponds to one element of the string. This is one digit or letter or any other string character. The rest are user-defined files. This means if I ever have a file that needs more, any type of information that needs more than one file, I can reserve another file and call it with the identifier, the same identifier, let's say bits, and then choose a file for it. Bits usually we do not need because we have a very large amount and we address them one by one. But if you go to strings or floating numbers, we could need more and we could use an extra file for that. This is the end of chapter 3. Thank you.